Okay, this question is asking you to draw an energy diagram. So draw a reaction coordinate diagram with respect to energy. So we have free energy here on this side, and this is the reaction coordinate on the other side. It wants it to be endothermic. And so now in organic chemistry, we're getting beyond our simple looks at reaction coordinate diagrams by saying, okay, products lower energy than reactants, endothermic. Now we're actually thinking about the change in energy across the entire potential energy surface throughout the course of the entire reaction. Particles in chemical reactions actually change change shape all along the way, and each one of those infinitesimal changes in shape has an infinitesimal change in energy associated with it. And so the energy coordinate diagram, the reaction coordinate diagram, is really continuous. It's not discrete like we've been showing it in general chemistry. It also has 3 steps, which means that there are actually intermediate product or intermediate species in that between the reactants and products. So going from reactants to products in a general chemistry sense is one step. So this discrete diagram, which I haven't made continuous yet, represents one step. But if I'm going to have a reaction that represents multiple steps, then that means that there are some other minima along the way. And what I need to do is I need to actually correct these other spots and turn them into minima along the reaction coordinate. Because transition states represent maxima, products and reactants along with their intermediates represent minima. And so I'm going to start out at some minima. I'm going to go to some intermediate. Now, the last thing that we need to take into consideration is that the third step is the rate determining step. What determines the rate of the reaction? Well, the activation energy determines the rate of the reaction. So a larger activation energy means a slower reaction, and the rate determining step is the step that is the slowest. So what we need to do is not only do we need to have 1, 2, 3 minima along the reaction coordinate after the reactants, we need to think about the relative positions of the transition states. We know that this is the first step. This is the second step. And this is the third step. Let's just be consistent. And we know that the activation energy of step 3 needs to be the largest. And so I've already arranged this so that we'll kind of have that work out for us. And so we can see that there's an activation energy for step 1. That's the activation energy for step 1. Here's an activation energy for step 2. And here's the activation energy for step 3. Step 3 is the slowest step, so it's the rate determining step. Okay.